say I don't control how they level those. All right. All right, we're all getting started here. So I'm going to be essentially recording everything that's going on so you can check this out online. We're going to be starting to actually build stuff, and actually today we're not going to be doing any coding at all. We'll be talking about electricity and things of that nature. And then we'll be building just one really basic circuit. That's why I'm in the back. So some of this you'll be able to see on the screen. I'll do my best to put that up there. But then if you watch this online, should be recording. There we are. You'll be able to see I have this camera up here so you can see all the stuff I'm building after the fact. And I'll do my best to put that up when I'm done going through the slides. So for the bell ringer today, getting started with there, basically in the box on the side of the room, you've got the little Arduino kits that I pulled out last week. I want you all to go grab yours. Also, right in front of me, it's in the box. You had the one that was left over. Right in front of me, there should be enough for everyone, are some little cables. I want you to grab one of each color on your way back. So it's a present from me. I want you to treasure them forever.
Oh, lovely.
Yes. Yep, just one of each of those colors. No. Those are for my demo. You should have the other cables you need in your kit. But just one of each of those. It'll, as you'll find out, it should make your life a lot easier. Yes. Should being the key word, but I mean, you could try, but they're super bendy, so it really wouldn't work. Yeah. All right. Okay, so I've just speaking of the Google Classroom, everyone did the bell ringer today. They got bonus points. Yay. We're going to be focusing on a few things. Specifically, a bit of each of the different kinds of physical computing. But we're going to start off today with just what is electricity? The bell's ringing. What is electricity? How does it work? How will it work with our boards and stuff? And at the end, we should have just enough time to make a very simple circuit with a light that lights up. That'll be the goal by the end of today. If we have to push some of it into the next class or anything, we have an extra day that any of this can get pushed back a little bit if we need to. But we'll start talking about digital signals, analog signals, and then combining all of that so that it talks with our code. So that's all there. And then we'll move into working with a final project, but I'll talk about that more in a few days. All right. So everyone gets bell ringer credit. You all grabbed your Arduino kits. If you open it up in the box, there should be a few things inside. The first should be a kind of plastic board. And attached to that should be a chip. Do I have a... So, again, you would have a plastic board, kind of like this. It'll probably have a cover on the back. But you may notice attached to it should be something that looks like this. I realize I'm saying that for the video people, so I'll hold this up. But it looks kind of like a white panel with a bunch of little holes in it. Yours may be the longer one. There's no difference in between these. This one's just twice as long. And the circuit board, the Arduino here. So you should, again, you can see that right there. The Arduino is what's going to be working all of our code and managing the electricity. So specifically, we have a kind of mid-size one. They come bigger than that. I have some that are much smaller. But they basically all do the same thing, and that is that they have pins that can detect and output various electrical signals. So again, everything will be set up for the Uno sized board, but they do make bigger and smaller ones if you wanted to get your own kit. They aren't terribly expensive. There should be a few other things. You should notice a bunch of cables in there. You're going to need those. Don't lose them. Keep the ones I gave you, like hold on to them, but keep them slightly separate for now. These are going to have a specific purpose a little bit later. You should see a bunch of little, I don't know how I would describe these, like little blue or brown striped beans on wires. All right. Not quite. They look like this. If you don't see, they may be in between like two brown strips of paper holding the ends. If you don't see them, that's these. Again, it looks like kind of like a little blue thing with stripes on it, and then about an inch or so of wire coming out of each side. The wire may be a little beat up if it's been used before. Not quite. I'll put one on your table over here.
I have a bunch of mine.
Yeah, you may have to share. You can have this one now. Like I said, you may have to share. I've got a bunch of them. So if someone needs one or two, I can pass them along. My Arduino kit's a little bit bigger than your kit's.
Is there a difference between like the yellow ones and the blue ones?
Yeah, yes. But the biggest difference is in the stripes on them. I'll talk about that in a second. But if anyone needs resistors, I have a whole tray full of them.
Here they are.
Awesome. You can hold on to that one I gave you if you want. They're cheap. All right. Other than that, I think you should notice a little LED, a little light bulb. May look like candy. Don't eat them. They're probably mostly red, maybe some yellows, maybe some greens or blues, but I think red is the cheapest and the most common that I've seen in all the kits. And then you may have a variety of other stuff that'll generally have 2 or 3 or sometimes 4 little wires coming out of it like the resistors. And I'll talk about what all that stuff does. Generally they'll be in bags. But that's you should also have a USB cable. If you don't have a USB cable, you might have an issue. Does anyone not have the cable or the circuit board? Yeah. You'll need this. If anyone's not missing that, I'm gonna move on. So I've got these slides, and these will be on the screen. And also, if you're watching the video with the cameras, granted it'll be delayed from what it's happening right now, but you'll be able to see the slides on the screen as well. All right, so we've got kind of 2 main things that we're going to be using in this course: the electronic components, and that's the assorted bits of everything, all the parts and stuff that you might be seeing, the wires, the resistors, the lights, the dials and switches, things like that, and the microcontroller and the code. So the Arduino is a microcontroller. And again, that just controls different kinds of output signals leaving the device, as well as monitors input electrical signals coming in from whatever you've connected to it. And we can program code to tell it how to respond and what signals to send out and things like that. And we'll be getting into that a little bit more on Wednesday. So in order to utilize any of this, we have to ask ourselves, what is electricity? Because while we've been using electricity for all of our stuff so far, the computers are running electricity and they take it in order to execute the code. We haven't really been using electricity, and I put air quotes around that, in the sense of that's only what we're doing. So electricity is kind of the flow of little particles called electrons. If you haven't taken a chemistry class, then on the atomic level, so very, very small, atoms are generally made up of protons, which are not molecules, these are smaller than molecules, particles with a positive charge, neutrons, which have no charge, they're neutral, and those kind of exist in the middle of the atom, kind of in a relative clump. And then around that, kind of floating around at different levels, are these electrons that have a negative charge. Because they're floating around the nucleus of the atom, and they're very tiny, it's very easy to kind of bump those off and you move them around, essentially. All right, and basically you can move them around, and they move differently through different materials. And that is basically when they can't move through something, that's called an insulator. And when it can, that's a conductor. You may have heard those terms. And again, that's just broadly speaking. So things that are very insulative don't let that electricity, those electrons, flow through them. So like these wires, the metal part is very conductive. So the electricity flows through the metal, but the little rubber coating is not. That's very insulative, so it doesn't jump out and shock you. Air is another good insulator. That's why when you unplug something, usually this shouldn't happen. The electricity doesn't arc from the wall back to the plug and keep going. If it does, that's a problem. That being said, the insulator and conductor is kind of a relative term, because if you try hard enough, you can send that electricity through just about anything. Lightning travels through air, but lightning is also way more powerful than what we'll be using. We'll be using all low-level stuff, and this, as long as you're not like deliberately trying to break something, you won't get hurt. So electricity kind of has three basic level characteristics that we'll be concerned with in this course. There's other stuff, but we don't need to get into that for the purposes of what we'll be doing. What those elements are is voltage, current, and resistance. And these are all related to each other in a specific way. And it's this relationship that's going to let us kind of figure out what's going on in these circuits. So basically, an electric circuit we can kind of compare to kind of the flow of water is one of the ways I like to think about it. So I've got this diagram on the screen. I've actually got two here. So basically, I like to think of it this way. So the amount of water flowing through your circuit, again, kind of using the analogies, but the water flowing through is the amount of current. So if you have just a little trickle of water compared to a full-on, blast from a fire hose, the blast from the fire hose has much more current. The water pressure is kind of equivalent to the voltage. So looking at this diagram up here, again, we're putting water up to the top. That's generating more pressure up here, so it flows down. So as it moves up, the water gets pumped up. We get more pressure. There's more voltage up here, and it wants to move back down. Resistance would be anything in that flow of water or electricity that kind of blocks what's going on. You can see that a little more clearly in this diagram. We have the current up top. We flow down, and then the voltage is pushing it along back up. And then the resistance here is kind of pushing it through. I like to think of it like if you've ever taken a water hose and covered up the end with your thumb, it's the same amount of water still going through, but it's there's a lot more resistance, so there's more water pressure involved. You can kind of see this relationship also explained in this picture that will be on 3 slides in a row. So if they had anime girls in my physics class, I would have paid more attention, just saying. All right, so voltage. Again, this is the force that pushes the electrons through the circuit. If it was a waterfall, it would kind of be the gravity that pulls it down. So between any 2 points of the circuit, it's the amount of energy, essentially. So you can measure voltage between 2 points, but you're always going to be checking for the volts of the circuit. In this class, we'll be doing things with, I believe it's all just 5 volts. You can also connect it to a 3.3 volt pin on your boards. Again, but that'll just be less power because there's less force pushing the electrons through our circuit over and over again. We can see in the diagram the voltage is pushing the electrons through the circuit. Current, again, that's the number of electrons. Again, the amount of electrons flowing through the circuit. So if there's a lot of stuff to push through, it's going to need more voltage in order to get it through. So again, you can measure this anywhere in the circuit, but we measure this in amps. So if you ever hear me talk about amps, that's the current of the electricity. And again, sometimes you could have, very, very powerful or just a little trickle. It can vary. Resistance, again, is anything that's, kind of blocking that flow of electricity and kind of stopping it from flowing as smoothly. You'll also hear this called the load, but we also measure this in ohms. So again, you can see the more resistance there is, the harder it is to squeeze, for the voltage to squeeze the amps through the circuit. And again, just to kind of illustrate this, I have a tool here. So again, you'll be able to see this watching the video, or if anyone wants to just come look at the screen. But everything has some kind of resistance. So again, if I was just to check the resistance of my finger, at the moment it's going to be changing because it's my finger and not an electrical component. At the moment, it's somewhere around 3.7 million ohms. But if I just pick up this wire and check these 2 points, it is 0.5 ohms. So again, it's a big difference in that amount of resistance. So that's why the current is going to flow through these wires and not through you. Again, don't try to break something and everything will work fine. I'll talk more about resistors and stuff like that as we go because they will be your friend. Power sources. So basically, the power source is what generates all of these circuits in order to be able to make them work. So this is what kind of gives it that voltage in order to push the electrons through what's going on. With a battery, again, you've got that negative end versus the positive end. So as the electrons flow through the battery, when they get from the negative to the positive, they get energized, and they keep going through the circuit. And that's kind of the main point. You'll notice on batteries, do I have a battery with me? I don't. I didn't bring my battery case. That's okay. But again, there's that negative and positive end, and they always have a specific voltage. So a 9-volt battery will, again, energize the electrons going through it by 9 volts. And then you can find that on every battery that you can find. So again, I mentioned that these are all related. Okay, and we can kind of talk about these relationships through Ohm's Law, in the sense of the voltage, the current, and the resistance. So if we wanted to find out the amount of current, and we knew the voltage and resistance in our circuit, we could very easily just say, okay, the current is equal to the voltage divided by the resistance. Because these are only 3 things, it's rather easy. You can also rearrange it. So the voltage is equal to the current times the resistance, and the resistance is equal to the voltage divided by the current. So you can combine all those. So if you ever need to figure something out about your circuits, we can go in and use this law. The most common thing we might run across is needing to figure out what size resistors to use. Although for most of the things, we'll really only need one or two specific sizes. But that's kind of the most applicable use of it, is just this little three-way relationship. Most of the time I see it written as V equals IR. If you've ever heard the term watts, that's responding to the electrical power, and that's just the volt times the amps. So power equals VI. So if you ever need to figure out the watts of something like a light bulb, you could figure that out with this little bit of simple math. All right. So I've said the word circuit a lot, so I'm going to just talk a little bit about what that is. So a circuit is a closed loop for this electrical energy to travel through. So there's always a source of the energy, whether it's the battery, or in our case, it will be coming through this little USB cable here into the board from our computer. So I would highly recommend when we start doing this, just make sure your computer is plugged in, so that way it will sap the battery faster. I don't think it'll be anything too crazy, but that will be the case. So just make sure it's plugged in, and you won't have to worry about a dead battery. Again, the electrons flow from the negative side to the positive side, and then through whatever components are also hooked up. So you have to have this loop here. All right, it's not going to work otherwise. And then there's some kind of resistance and things like that, and all that combined will eventually power whatever you've hooked up. We're going to be, by the end of class, making one with a light. Could someone tell me, I'll go back to Ohm's Law, but what would happen if the resistance in the circuit was 0? The answer's on the board, but if we pull back up the math, like what would happen if there was 0 resistance in there? Yeah, you can't divide by 0, and basically that's a problem. So again, you have to have some kind of resistance, otherwise too much electricity is going to go through the circuit. It's going to essentially blow up and not work. Then we just use these wires right here. You should see a big bundle of them in your kit of a bunch of different colors with these little pins. I'll either call them wires or jumper cables, because they work just like jumper cables for your car, only much smaller and much less deadly. So that's what we'll be using in order to do all of this. So we've got just a few little thought experiments before we move on. So if I was trying to power this light bulb, would this work? No, it would not. Yes. What about this one, though? Are you sure? Exactly. So I'll say, so it is forming a closed loop, but you'll notice it's going from the light bulb to the positive end of the battery back into the light bulb. It's never reaching that negative end, so the electrons can't get re-energized to power the light bulb. So this will not work. So this is what we would need. And again, that's going from the negative end of the battery through the battery to the positive end. We connect to the light bulb and then back to that negative end. We're going to assume all the resistance stuff has worked out just fine. But again, we can see that this closed circuit, if you've ever played Mario Kart, you're on the circuit. Okay, you're looping around back and forth, or not back and forth, but in circles. And that's what we need. So if you ever don't have it all connected up properly, you're just not going to get anything powered on. Your electricity can't flow in this repeated pattern. Okay, so let's talk about what we need to make them. So I mentioned some of this stuff already, but you should have a bunch of components in your kit, and these are going to be what we need in order to work. Resistors are probably going to be both the simplest and the most complicated / useful things that we would need. There's a bunch of different kinds. We have these ones that, again, look like little brown or blue beans with wires coming out of the end. These are what's called fixed resistors, meaning if you plug this into your circuit, it's going to be the same amount of resistance every single time. So I plug this in, right here I'm going to get 220 ohms of resistance through on the current that's running through these wires. And actually all of these on my table are 220. We have that there. This is different than a what's called a variable resistor, of which I've got two kinds here. You can, if you're again watching the camera view, you should, if you have these in your kits, they'll look like some kind of dial. Again, there's two kinds that kind of come commonly with these. These kind of bluish ones with an arrow that you can kind of turn, or it could be this kind of metallic looking one with a drum on it. You'll notice they all have three little pins coming out the bottom, but you can turn it. If you don't have that, we'll be able to work through that for the lesson. But it looks like we have the big ones. So again, I'll hold this up so the class can see it. It kind of looks like this. If you don't have it, that's okay. It looks like Chastity has some we could at least share. I've got a few extra for when we get to that lesson. But it looks like everyone more or less has one. These things, compared to the fixed resistors right here, these little blue and brown guys, when you turn the dial, it changes the amount of resistance in the device. So you're able to change the electricity going through it. There's other kinds, but we'll get to those in a second. We'll talk about circuit diagrams a little bit later, but when we look at them, there's specific symbols that represent resistors. So the most common one I see is this little squiggly line. So if you ever see an electrical diagram in this, that'll tell you that that's a resistor. And then the most common one of the variables has this arrow going through. So if you see this, maybe there's a dimmer switch on the light circuit or something like that. Okay, so what do the colors mean? It looks like these are all here, but you should have a little sticker kind of thing that details this a little bit, but I'll make a diagram like this available for you all. But this is how you read the resistors. So you'll notice these are kind of small. It's very hard to print the numbers on these. So the way the manufacturers decided was that you could identify how much resistance was in a resistor by the colors. So generally there's, I think we all have the blue ones, right? If you have the brown ones, they function the same. But you'll notice that there's a different number of bands on them. All right, so again, I'll on the camera here, hold up the blue one with that many bands next to the the brown one with a different number of bands. Okay, so the way we read this is basically the first band, that tells us a number. All right, and we can see what that number is on the side there, 0 through 9. The second band tells us, another number. And then if you happen to have, I think on the blue ones, we have one more, and that tells us 3 numbers. And then the very last one is a multiplier. So that tells us you take the number from the first series that we get and multiply it by the last ones. I'll walk you through this in just a second. The very last band is what's called the tolerance. So these are mass-produced and not completely identical. So these are all, it's this amount of resistance within so much tolerance. I think most of the ones we have are gold, but there might be some browns in there. So if you look through some of these, like this one here, this brown one, if you have a brown one, it will have some color bands and then the gold. This gold, or sometimes silver, sometimes it's brown or red, but generally gold or silver, that's always going to be the last band, this one on the right side. So that's how you'll be able to line them up and know what we're talking about. This one over here, again, it can get a little more ambiguous if you have brown on both sides, but I don't think we'll be working too much with that. we have here. So I've got this resistor that I'm looking at. So if we look at the first band, that's a red. So that would be 2. The second band, that's also red. So that would be 2. The third one is black. So that's 0. So we get 220. And then the last one, before we get to that tolerance band, is black again. So we can see that those multipliers, that's 220 times 1. That's 220 ohms. We can, I can verify this. Again, I'll have this on the screen, but with my little resistance measurer, I can connect both ends to it, and it will come up at 220.1 ohms. So the system works. So again, if you find, here's another one, that 220 with that red, I think those are red. Those might be, they're definitely not purple. I think they're red. Like I said, it's hard to tell the color. I agree. The system works, but it's not my favorite. But so I think this would also be the 220 because you get, going back, you get 2 and 2, so 22. And then brown would be 22 times 10, which is 220. Basically, this second to last ring tells you how many zeros to add beforehand. So you get 0, 1, 2, 3, 4, and so on. So you can get really small ones. I have some that are like 5 ohms, and I have some that are like 2.5 million ohms. So you can get a lot of variance right there. Real quick, I want you all to find, again, if you have the blue ones, the ones that are red, black, black. Because we're going to need the 220 ohms for the end of class. So red, black, black. If you can't find that, let me know. I've got a few extra. You could also test it with my multimeter if you need to. But again, you're going to need to find a red, black, black. And then if it's the brown ones that you have, it would just be red, brown. We'll give you all a second to look through them. Are yours brown or blue? Blue, so we want red, black, black. And then with the very last one would be brown, but or gold or silver.
Okay. So red, black, brown?
Yes.
Okay.
And again, that just tells you numerically how much resistance is in the component. So you should all have this little sticker diagram that breaks it down for you. Don't lose that, because that is your best friend. I have 1 or 2 I might be able to share if someone needs it, but I'll find a digital version and put it online. Is anyone having trouble? Yes, no? All right, I'm going to move on for the sake of time. Okay, switches. Switches will also be your friend. These are things like buttons. Buttons right here, so you can press them and they click. Right there, you can see some examples. Or there can be other switches where you move it, from left to right, kind of like a light switch. These are kind of the most basic component used in order to adjust the flow of electricity. And basically, there's 2 different what's called leads. And these are the pins on the back of these components. These are also called leads. And basically, when you activate it, you can, you connect them and the electricity flows through it. It's basically a wire. These are a little more sturdy just to handle being pressed into stuff. But you connect it and it goes. Again, we've got this little diagram here. So if this is the circuit wires, the circuit, it doesn't connect, and then you can close it down, and we go. There's a difference between a momentary or a toggle switch. A toggle switch, kind of like this one I'll have on the camera, And again, if, at the end of class, if anyone wants to come look at these, I've got a whole box full of them. It's just that we can't just crowd around right now, unfortunately. But this is a switch, like a light switch, where when you you switch it and it holds its position. All right, so like it's on, and then it's off, and it stays there until you switch it back. The momentary switches, like the buttons, you press them, and as soon as you let go, they go back to their previous state. So if this button, kind of like that third one on the screen, would be like a light switch, it would be a very bad light switch, because in order to have it work, you would have to sit there and hold it for as long as you needed the lights on, because it would only be letting the electricity pass through it while it was being pressed, and then it would go back to the off state. So there's two different kinds of switches, generally speaking. So depending on which one you use, that may or may not be problematic. I'll get into the details of the other kinds of the pins and stuff later. Another kind of switch is a tilt switch. So you may or may not have one of these in your kit. It looks kind of like a little black cylinder with two pins coming out of the side. And if you shake it, it kind of rattles. I don't know if you can hear this or not. Again, you may or may not have this. My kits are a little more expansive than yours. But basically, there's a little metal ball in it, and when you tilt it, the electricity can travel through the ball and out the other pin in that circuit. So if it's tilted one way, the circuit can't travel. If it's tilted the other, it can. So that's kind of what that looks like. Again, if anyone wants to get a closer look at these when we're done, feel free to come up and check them out. But you may run into a tilt switch. What we will be using the most in this class is a thing called a diode. And a diode is something that lets electricity flow only through it in one direction. So a lot of these, like this resistor, if you had it lined up one way in the circuit, you could twist it to the right and it would increase the resistance. Or you could take it out and flip it around and put it the other way. So now when you twisted it to the left, it would increase the resistance. The electricity can flow through it both ways. This is not the case with a diode. And there's a bunch of different kinds, as you can see on the screen. A diode has a specifically positive and negative end. And if it's not hooked up the right way, the best case scenario is that the circuit just doesn't turn on. The worst case is that it explodes. In this class, we shouldn't be dealing with anything powerful enough to make it go boom, but that can be a problem. On a diode, you can tell the difference between the positive and negative end, also called the anode and cathode, if you ever see those words. The anode, the positive end, is the longer of the two wires coming out of it. We'll specifically be using, I'm sure you've heard of this, an LED or light emitting diode. And again, you should have a bag full of these. I think they're mostly red. And you should notice that one pin is longer than the others coming out of the bottom of them. The one I'll be using in my video is blue just because it lights up a lot brighter than the other ones. But that's we have that there. They use very little current, and they usually work on the right voltages that we'll be using for this class. So that's why we'll be using them, because they're very easy. Other components, capacitors act like little mini batteries. So if you need to like run a motor or something, it can store up electricity and then output it all right at once. Transistors and relays are switches, but they can be powered by an electronic signal from your Arduino board. If we get into this, we'll use them, but there's a large amount of components that would take way too long to get into. So I'm not going to get into it right now, but depending on what we need to make, we may have to pull out a capacitor or a transistor. Well, just kind of depends when we get into that final project. Okay, we're almost done with this part. Again, the circuit component symbols, there's two kind of ways we can represent electronic circuits. One is with this kind of wireframe setup. So again, you'll be drawing rectangles like represent the wires, and then different symbols would represent the components. So you can see the resistors, the switches, the LEDs, things like that. These various symbols represent different things. These also have little letters that go after it. I'm not going to go into too much detail, but this just kind of helps you figure out what's what. So again, resistors, diodes, switches, those are kind of the most common ones we'll run into. Here's an example just so you can see what we're talking about. So we have a battery here connected to a resistor of 220 ohms, connected to the positive end of a red LED, and then that negative end just goes to the ground of the battery. So this is a full circuit. All right, the last kind of big important thing to do with this PowerPoint is to talk about whether we build something in series or in parallel. So when we build something in series, if that would be like we took our circuit, and let's say we connected the light up, get in there, the light up, and then we connected that to another thing, and then that to another thing, just one after the other. And kind of how we see those lights right there. Well, the current has to go through one device, and then to the next, and to the next, back to the battery. So if at any point you break that current, it's going to stop the whole flow of electricity. To contrast this, we have a parallel circuit. And as you can kind of see in the little diagram beneath that, the electricity is able to branch off. So we get the positive end connecting to the first device, and then that negative end goes back to the battery. It branches off for the next one where it's the same thing, and it branches off instead of being connected in a row. So because there's multiple paths for the electricity to take, the other components would stay powered even if we got rid of one of them. This is how a lot of Christmas lights work. So if you've ever had those older ones where if one light goes out, the entire strand goes out, those are built in series as opposed to the ones in parallel. Generally speaking, parallel is better. Again, that's real broadly speaking. We'll find pros and cons to each of them depending on how we build stuff. This is just, I'm not going to get too much into it, but again, a series circuit, we've got the resistors in series, so one connects to the other, versus parallel, where it branches off for one versus the other. I have a video of me going through this in a lot more detail. If you want to check that out, or if you have questions, you can ask. But I want to get through the important stuff so we have time to actually build a circuit by the time we're done. All right. So the one thing I mentioned before that I haven't come back to is on your little board with your Arduino should be this white, red, and blue looking board. I think all of you have the long ones, which are great. They come in kind of a long or a small size. They function the exact same way. It's just one is bigger, so you can fit more stuff. These are great. These are called breadboards, and these are great for being able to prototype different things because they can help you control the flow of electricity, and it's very easy just to pull out old things and put new stuff into it. You can kind of see an example on the screen there. It looks like we have a light hooked up as well as a little buzzer that you could turn up with a potentiometer. The electricity flows through these things in a very specific way. The first thing you'll notice, generally marked blue and red with a positive, negative, and it goes along each side. All right, these go vertically here. You can kind of see on the diagram these lines illustrating that. So you will connect one end to the positive power from your Arduino board and the other to the ground on the Arduino board. And this will travel all the way down the length of the board, so that way you can very easily, from whatever component you stick in here, just connect it very quickly to power and ground as you need. Then all of the kind of numbered rows. So you'll notice, 1 through, I think I have like 65 on this long one, but a bunch of little horizontal rows, and those are all connected. So again, I'll be kind of holding this on the camera here. So if I wanted to connect this resistor into here, I could connect it somewhere down lower on the board, and everything that's horizontally related to these two rows, actually let me move it down so it's on 5 and 10, could connect to whatever that resistor is connected to. So again, you can see that on this diagram right here, everything here is connected. So if I have electricity coming into this pin, whatever I connect to these other ones will be getting that same electricity from this source. As we do more and more of this, I think it might become a little clearer if you're a little confused. What I do want to point out is this groove along the middle, all right, of your breadboard, right there. So the left and right sides of this board are not connected. All right, they're two separate, essentially mirror images of each other. And this is where these wires I gave you are going to come into play. So it's going to save you a bunch of headaches if you just connect the left and right sides to power and ground. So I want you all to take that gray wire I gave you and plug it into the negative on one side of your board and the negative on the other. I'm just going to hold that right there. And then take the orangish reddish one and do the same thing with positives. You can bend the wires, that's fine. But the ones I gave you specifically kind of bend and retain their shape. So these can just live like this, and I'll hold this up and from the cameras in a second, and then for the class, just to make sure you've got this up and going. If you just leave it like this, you don't have to worry about forgetting to hook up your other side when you try to do your things. So again, I'm going to hold it up. That does work. I do mine on the same side. But again, you want just to make sure that it's negative to negative, positive to positive. And I'm going to specifically request that you stick the orangish one on the positive and the grayish blackish one on the negative. Like across the board. So yeah, so like so down here, if you have it plugged into the negative side, go across and plug it into the negative side on the other end. So then, yeah, so let me see if I have a, like this. Do exactly this. So you see how the red one is connected to both the positives and the black one is connected to both the negatives because they're not connected. Just going to go look at these slides just so I make sure I didn't skip something specific. We'll be using the wires. The red ones in your kit, that'll be for going directly to power. So from the power source, black goes to ground. You can sometimes see green or white used, but generally black goes to ground. And then you use all the other colors for everything else. So you can see the positive has the red from the power, the black is the negative going to ground. And I just gave you the colors I had that were closest to that. All right, let's move on. I'm going to talk about diagrams in a second. We'll be mostly working with this kind of diagram right here, but these are essentially the same thing. You'll notice we get from the positive to a resistor, to a switch, LED, to ground. So we get at the positive end of the battery to a resistor. The resistor is here because these are horizontally lined up. That's connected to a switch. Horizontally lined up to an LED. Notice the longer of the wires on the diagram is the one facing the positive end. And then out the LED to the negative, which connects just to right here, and then back down to the negative end of the battery. Again, we'll get more practice doing that. Again, same kind of thing, 5 volts to positive, negative at the resistor, to a button, to ground. So in this particular switch, whenever you'd hit the button, it would complete the circuit and the light would come on. And this is actually the last one of this. So what I want us to do right now is we're going to go to a web page. So you're going to need your computers, and this is going to be a web page where we can make these diagrams. And this will be very helpful, and this will be a large part of what we turn in for this course. So I'm going to leave that. And then I'm going to go to TinkerCAD.com. TinkerCAD. CAD stands for computer-aided design, but it's TinkerCAD with a D. My page is going to look a little different than yours, but you can make a free account. So if it says, like create account, log in, something on there, you can do that, and you can use just your normal school ID. So if you, in fact, just go into like log in with Google in your normal school ID stuff, that should just take you right there. But this is how we're going to be creating the diagrams we need for this. If you've done things with the robotics class, you may have already done this, or some of the engineering classes may have used this already. I know Mr. Island likes it. There's other ways you can do this. I have a program I like to use, but that program costs about $10. So I mean, you can buy it, but I'm not going to make you buy anything for this class. This one is free. So once you've gone through and made your account, you should see a page that looks relatively similar to mine. I haven't put a picture or anything on there. But on the side here, it should say circuits. If you click on that, this is not the same one, but you should have an option with a green button. In fact, actually, if I delete this, I think it will. Yes, I'm sure. There we are. You should see try circuits. And I want you all to click on that. And it will pull you up to this. And this is going to be a little tutorial for how to utilize this program. So it's, I want to give you all about 10, 15-ish, I'll say 12 minutes to kind of work your way through this. There's kind of 3 main sections. So you're going to follow the instructions on the left here, and eventually you'll get to done. And actually, I'm on the last page because I've already done this. So again, follow the instructions, and I'll give you all a few minutes. I'm going to make a circuit diagram that I'll put up here, and at the end of class, we'll all be making one. Nope, come back. This one? Clicked on the wrong thing. Do it. Oh, I should have gone back to project page. This is just... There we go. Circuits. You start getting through that at 2:15, I'll move on to the next thing. It's about 5 minutes from now. So if anyone's watching this after the fact in their little recording, you can skip ahead about 5 minutes. Let me just make sure I did this right. Okay, cool, I did that right. All right, so as we are coming up on the end of that, I will say that for this course, generally when we do code for the Arduino, you'll turn in the code. I'll come by and I'll see that your circuit is or is not working and give you tips on that. But the thing that's important to do is that from here you could hit share and download a snapshot of your design, and that will save it as a picture. You can then turn in that picture to the assignment. So you'll be able to make basically plan out your circuit beforehand, make sure that it's working in the program, and then you can build it based off of your thing. It'll be like a blueprint. So once you make it and the simulation is working, you can turn in that picture, and that'll be parts for the grade. Is anyone still wrapping up the little tutorial stuff? I'll give y'all just a second. I'll turn in a picture of this diagram for you all once we're done. But basically what we're going to wrap out class with is creating this little circuit. So the goal is to have we'll start with just one LED, and if we have time, we'll move on to the other. But once everything is up and going, that the LED lights up. That's going to be our goal. So in order to do this, and this is kind of the whole point, I have the second camera here, so you can watch this after the fact. I was going to put it in the Google Classroom when I was done. For now, it'll just be on the wall. But you're going to want to connect the USB cable to the computer and then connect the other end into your Arduino board. You should see a light come on right next to the word on. If that doesn't come on, it's not on. But it should flash a few times, and there should be another light. It may start doing some other stuff with other lights. Depends on the code that might be saved to this thing. We don't have to worry about that right now. We're not working with the code. We're just dealing with electricity. So next to that, you should have your breadboard. I think everyone's has it just connected to that piece of plastic, so you don't have to worry about losing it. But I want you to take a red wire, and how I have it on the Arduino, you should see on one side where it says power, one that says 5V or 5 volts. Plug one end into that part, that little plastic housing on the Arduino, and plug the other into a plus sign on the end of your breadboard, just like that. Yeah, you should have plenty of red wires. I want you to do the same thing with a black wire and ground. So I'm going to plug it into the ground on the other side. Actually, no, I'll make it match exactly. Ground to ground. So again, in the video, you'll be able to see this a little more clearly. I'm going to work out something a little bit. But actually, can I just?
So from 5V to where?
All right. So you see the little diagram I've got up on the wall. You get the 5V. That's going into that kind of plus row on your breadboard. Anywhere is fine. I usually stick it at the end, so I have most of the board to work with. And then you want G and D. G and D for ground, and you're going to connect that to the negative. It's because I switched. No, do a black one. This way you can tell what's positive and what's ground, and you don't accidentally short your circuit. And because you have those wires I gave you, now both sides of the breadboard can get hooked up. Just like I have right here. So again, you can see I've got the positive and negative going to positive and negative on the breadboard. And then I've got them connected with these little wires on the end there. That's going to be the first step. The next step is going to be to take your LED out of, I think they come in a little Ziploc bag. Just take one out there. If you have multiple colors, for now it doesn't matter what color you pick. The one I'm going to do first is going to be a bright blue color. And we're going to plug that in to our breadboard. Well, this is getting angry at me for many reasons. That's okay. But we're going to plug that into the breadboard. You want to plug that in between two different, the ways we have it set up here, two different rows. So say you should see these numbers along the side. So I'm going to stick mine right here on 35, and then my other pin right above that. I'm going to, at this point it doesn't actually matter. I'm just going to kind of hold this up. The point is you want them in two different rows, kind of how I have it on the diagram, and how I'm, if you're watching the video after the fact, how I have it here, but in two different rows. You're going to need to notice the longer one versus the shorter one. You're going to want to take another wire, once you have your LED just plugged in, and you're going to connect it from that positive row to that longer pin. So I've got the longer pin for me is on 35, so I'm going to just take another cable and plug it one end into that, whatever you want at this point. Doesn't matter what color it is. And I'm going to plug it and connect the positive row to 35. So again, I'll kind of hold this up there. You can see this on the diagram up top. Again, we've got the LED positive is connecting to that slightly longer pin right here. Boom, boom. All right, so on your breadboard, you know that same row where you plugged in that red cable? Plug it into that row and then connect it to whatever column that you plugged the longer end of your LED into. Yeah, on the positive side of the LED. All right, we're not going to get to finish the second circuit, but that's okay. From there, you're going to, this is why I said go ahead and find a 220 ohm resistor. So this would be that red, red, black. You're going to connect that to the other end of your LED. And then connect that, the other end of the resistor, to ground. If you want to come look at mine for right now, and I'll try and get a better on-screen diagram. Again, I've got it set up right here as well. But if you wanted to come look at mine, you can come over to the table a few at a time. So again, once you connect it to ground, it lights up. So again, we've got positive coming from that 5-volt pin. We're connecting ground, and that goes to negative. So here we get it coming out of the positive, and that's connecting to the longer of these two pins right there. Coming out of that, get in there, this is a new one. Like I said, you may have to kind of get a little rough with getting these into the right thing. But once we've built the circuit, you should have a light pop up. So again, it's positive to the LED, the negative end of the LED to the resistor, resistor to ground. The only difference between this one and the one we didn't get to, the one we didn't get to today is that I put a button in between here. So now if nothing happens, but when I click the button, it lights up. Okay, let's look at yours. So so you need the resistor.
Yeah, I think I did this wrong.
Just here. So you've got that, that's fine. So we're doing it on this end. So let's go from positive to, all right, that's the positive. So you want the longer end, which was here. So we just want anywhere on this same row, you can stick it in. Now we need the resistor, and you can bend the wires. You should bend the wires. Stick it down. So you'll want to stick it in the same row as the opposite end of the LED, that negative end.
So right here?
Not quite. Let me just make your life a little easier. All right, everyone. That's going to wrap it up for today. I'll see you on Wednesday. Check out the recording and the diagrams if you have questions. Today, I'll pack up the kits. We'll get better about that as we go on. All right, so as you come back, we're almost there. So again, you got the positive to negative. These are just jumping over to this side. You got it going from the positive to the almost to the positive end of the LED. That's connected. The negative end of the LED goes to the resistor, which is just going back into ground.
Okay.
So that'll wrap that up. Don't want you to miss the bus. I'll pack up the kits.
See you later.
Let's go.